Our topic today is the motion under gravity. So when the particle moves on the surface of some object, then you use the general equation of motions, which are given as V is equal to U plus AT, S is equal to UT plus half AT square, and 2S is equal to V square minus U square. But these are the equation of motions when the particle is moving under the surface of some object there. When it is falling under gravity, then you use, or it is in air, then you use the equation of motions under gravity. So equation of motions under gravity, where A will be equal to G. Then our first equation, which is V is equal to U plus AT, will become U plus GT. The second equation will become S is equal to UT plus half GT square. And the third will be 2GS is equal to V square minus U square. But when you move upward or you throw a ball upward, then you take A is equal to minus G. And when you throw a particle downward, then it will be A is equal to plus G. And A and G have the same units, which is equal to meter per second square. There are three cases in this case of motion. The first one is when particle is thrown from the ground surface, it moves upward and then it comes downward. So this is the motion of that particle from O to A of the particle in air there. So at this point, its initial velocity is not equal to 0 because it is given some velocity at this point there. Then at this point, its final velocity will become equal to 0. Let's say that position is B. At A, again, it is coming downward to that. So this is coming upward, this is coming downward. We know that if t is the time taken by that particle to move upward, then V is equal to U plus GT, where V is equal to 0 because at B position the velocity is equal to 0 there. U is unknown, which is given to U. But because it is moving upward, so G will be taken minus. So T is equal to U over G, and that is measured in seconds there. But from B to A, it will take the same time from O to A and O to B and B to A. So it is has the same time there. So total time will be equal to 2t there. Then the total distance traveled by that particle, we can use this equation of motion. 2gs is equal to v square minus u square. Because it is moving upward, 2g is minus into s is, let's say, height h. V square is 0 square there minus u square. So h is equal to u square over 2g is the height obtained by that particle in moving upward there. So this is the height which is being obtained by these two particles in moving upward to that particle there. Now, we can have the second case. If a particle is, the word they are going to use, either projected or the word thrown. This means the initial velocity is not equal to 0. And if they use this word dropped, then it means u is equal to 0 there. This is the height h obtained by that particle. So the same equation of motions will be used for this part there. If it is dropped from this point A at a height h from the ground there, then you can use this 2gs is equal to v square minus u square. 2 you know, g you know, s is h is equal to v square minus u square, because u is calculated to be given there because it is projected or thrown. So v square will become equal to u square plus 2gh there. And this you can calculate the value of v for that part. But if it is dropped from this point A, then 2gs is equal to v square, which is equal to, as it is, minus u square equal to 0 there. Then v square will be equal to 2gs is the final velocity of that particle before touching the ground of that surface there. Now the third case. Let's say O is the ground and it is thrown from a certain height h from that particle upward, and it comes downward to that. So here is the position B where final velocity will be equal to 0. Here u is not equal to 0. This is the time t taken by this particle, and from B to C, let's say this time is t there. So for this particle, because u is not equal to 0, v is equal to 0. So first you will calculate the time for that, which is equal to v is equal to u plus gt. V is 0 there, u is there, minus gt, or t is equal to u over g seconds there. So that is the time taken from this particle from A to B. Then from B to C, here initial velocity will become equal to 0. And here the final velocity will become equal to v, which we are going to calculate. The height first, this is the height h1. So we will calculate the height h1 as 2gs is equal to v square minus u square, because it is moving upward from A to B. So 2 into g is positive into s is h1 is equal to v square is 0 square minus u square. So h1 is equal to u square over 2, g is negative. So that thing is equal to u square over 2g is the height h1 for that particle there. So the total height will become h plus h1. This is the total height which is measured in meters for that particle there. Now from B to C, the height is h plus h1. The time is t there. So we can use this equation of motion. S is equal to ut plus half gt square, where S is basically equal to the total height, which is h plus h1 is equal to u, because it is coming downward from the highest point B there, where this velocity will be equal to 0, plus half into g, which is positive, into t square. So T square will be equal to twice of H plus H1 over G, or T will be equal to the square root of this portion. And the total time will be T plus T1. T1 plus T is the total time taken by that particle. So the total time taken from A to C is T plus T1. So these are the cases when they are moving under the influence of the gravity or in air, then you are going to use these type of the equation of motions whenever the calculations are going to be calculated for this portion there.